Okay, so I'm going to get the screen up here. This is going to be a review of test 4. Let's see if I can do this while putting that there. Okay, so we want t to the r equals s in logarithmic form. So I'm going to identify the a, the y, and the x. And then we're going to rewrite it in logarithmic form. So that's the one I'm looking for. And that's going to be this one right here. All right, and now we're expected to go the other way. And we're going to write that in exponential form. So there's my a, x, and y. And so then we've got r to the t equals s. So I need r to the t equals s. Okay. All right. With this one, we're meant to solve that. So again, I'm going to do a conversion. A, x, y. And I'll have a to the y equals x. And so I'll have x cubed equals 125. Now 125 is 5 cubed, and so x is equal to 5. Or I could take cubed root of both sides. And if I put that in my calculator, that's equal to 5. All right. Okay. With this, we're going to use the logarithm rules. Okay, now the first thing I'm going to do is change this. A cubed root is the same as to the 1/3 power. Okay, now the exponent rules say you multiply that. And 6 times 1/3 is 2. And now by rule 3, we can take this and it'll come out the front. And then by rule 4, this is just going to be equal to the number 1. And so my answer is 2 times n. Okay. All right, for this one, we've got okay, so using rule number 1, I can put these together. And now I'm going to do the conversion. If it's log by itself, it's understood that the base is 10. So I'm going to have a, x, and y. So I'm going to have 10 to the first power equals that. I'm going to FOIL that. Then I can solve the quadratic if it's equal to 0. So I'm going to subtract 10 from both sides. Okay, and then I can see that will factor. And I can see my solutions here are -4 and 3. Okay, now I have to go back and check in the original equation if they're allowed. If x is equal to -4, then this becomes -2, and that's not allowed. So -4 is an extraneous solution. Now I go back and check 3 in my equation. If 3 goes in there, I get positive 5, so it's okay. If 3 goes in there, I get positive 2, so it's okay. So this 3 is a solution. So the only solution is x equals 3. So my solution is x equals 3, and my extraneous solution is x equals negative 4. Okay. All right, and so we've got another one like that. Okay, so again, all right, I can put these together using Rule 1. Then I'm going to do the conversion. Okay. All right, let me just, okay, so we're still going. Okay, so I'm going to have 2 to the first power equals this. So if I FOIL this out, I'm going to have 9x plus 8x. And 9 times 8 is 72. I can solve a quadratic if it's equal to 0, so I'm going to subtract 2 from both sides. I can factor this, 2 numbers that multiply together to give me 70, but add up together to give me 17. Well, that'll be 10 and 7. So I'm going to have x is negative 10, and x is equal to negative 7. Now, I have to go back to the original equation and see if they work. If x is negative 10, then this will become negative 2. And I cannot take the logarithm of something negative. So negative 10 is going to be extraneous. Now what about negative 7? Well, if I take negative 7 and plug it in here, then I get positive 1. So far it's okay. If I take negative 7 and plug it into here, I get positive 2. So negative 7 is just fine. So negative 7 is our solution, and negative 10 is extraneous. Okay. Now for this one, we're going to end up using the uniqueness property. Okay, I'm going to put these together using Rule 1. Now I have single logarithms on both sides. So if I have single logarithms on both sides and the bases are the same, then the arguments are the same. So x plus 4 times x minus 2 is equal to 4x. I'm going to expand that. Then I'm going to subtract 4x from both sides. And I can try and factor this. 2 numbers that multiply together to give me negative 8, but at the same time add up together to give me negative 2. Well, that's going to be negative 4 and positive 2. And I can see my solutions to this are x is 4 and x is negative 2. Now I need to go back into the original equation and see if it fits. If x is 4, then this will be positive. If x is 4, that will be positive. And if x is 4, that will be positive. So x equals 4 is a solution. Now what happens if x is equal to negative 2? If x is negative 2, I'll get positive 2 there. So far so good. But unfortunately here, if x is negative 2, then I get negative 4 inside here, and it's not allowed. So this is extraneous. So the solution is 4, and the extraneous solution is negative 2. Okay, now the instructions here clearly say the exact solution. You're not allowed to give a decimal. And just because if you get it in your calculator to 9 decimal places, that's still a decimal approximation. No decimals allowed. Okay, well I need to do a conversion. If it's ln, then the base is e. So this is my a, all of that's my x, all of that's my y. So I'm going to have a to the y equals x. So it's going to give me e cubed equals 4x minus 1. Now I need to solve this for x. So to get x by itself, I'm going to add 1 to both sides. And then finally, to solve for x, I'm going to divide both sides by 4. Now it says to give your answer as a simple fraction, and that is a simple fraction. Now if I was going to put this into WebWorks, the numerator has more than one term, so I need to have it inside parentheses. That is my exact answer. Okay, that's your exact. If you put that into a calculator and get a number, it's going to give you a decimal approximation. So what's required here, and also it said enter your answer as a simple fraction as you would in WebWork, but I was still getting folks putting in decimal answers. Okay, so that's divided by 4. So that's what's required for that one. Okay, again, we're asked for an exact answer. Okay, I'm going to put these together using rule number 2. So I'll get a quotient, and in the numerator will be what's in there, and in the denominator is going to be what's in there. Okay, and now I'm going to do the conversion. Okay, so I'll have 8 equals that. Now I want to solve for x. X is in both the numerator and denominator of this fraction, so get rid of the fraction. Multiply both sides by x minus 4. So this will cancel, and distribute the 8 through, and I have x plus 1 left there. So subtract x from both sides and add 32 to both sides. So I'll have 7x equals 33. And then to solve for x, I divide both sides by 7. This is my exact answer. Fractions are exact. So no decimal approximations, no putting that into your calculator. That's my exact answer. Okay. This next one, it's compounded quarterly. So n is equal to 4, and the formula I need is that. Okay. The starting amount is 3,500. The rate is 6.4%, so R is 0.064. N is equal to 4 because it's quarterly. And the time is 10 in 10 years. Okay. So I'm just going to put this into my calculator as it is. And I don't round to the end and give the answers in dollars and cents. That means you round it to 2 places. So I'm going to have 3.5, then parentheses, 1 plus, no rounding until the end. Then to the power of 4 times 10, which is 40. I'm just going to put 40 in. Okay. And so at the very end, I'll round it to 2 decimal places because it's dollars and cents. Okay. All right. So, and use the dollar symbol. Okay. Now, how much would you have to invest? Means they're asking you how much would you have to start off with. So we need to find P. To get 10,000 after 4 years at 3% compounded monthly. Monthly means n is equal to 12, and it's compounded n times a year. So again, I use this formula. So 10,000 is how much we want to end up with. We want to find P. R is equal to 3 divided by 100. N is 12. And so to the power of n times t, 12 times 4 years. And 12 times 4 is 48. And so to get P, I'm going to need to divide both sides by that. So this is how much money I would need. And again, I want to give my money in dollars and cents. So I'm going to put that in my calculator, just as it is. So 10,000 divided by, in parentheses, 1 plus 0.03. Don't round until the very end. All to the power of 48. Okay. And so that's going to be 8870 and 53 cents. 8870 and 53 cents. Oops. Okay. All right. We're told here that it's continuously compounded interest. Okay, so that's our formula. R is going to be 0.058, and 7,000 is what we start with. Okay, so what is the doubling time? How long till we get double what we start with? So we want to end up with 14,000. And we want to find how long that's going to take. So I need to divide both sides by 7,000. And now I need to get t out of the exponents. So the base here is e. I'm going to take natural logarithms of both sides. Rule number 3 of logarithms, the exponent comes out the front. The natural logarithm of e is just the number 1. So I have 0.058 times t times 1. And I need to solve for t, so I'm going to divide both sides by 0.058. So this is how many years it will take. That's my exact answer. To get my approximation, I'm going to do ln of 2 divided by 0.058. Okay, so if I take it to the nearest year, That's going to be approximately 12 years. Okay, so 11.95 years, approximately 12 years. If I look at the selections, the only one it can be is 12. Okay, now we have a radioactive substance modeled by that formula. And what is the half-life of the substance? Okay, round your answer to the nearest day. Only give the number, so don't write, if it's 12 days, don't just type in 12, don't type in 12 days. Okay, so we've got this is my formula. Okay, and we want to know the half-life. So that means how long until there's only half left. Well, what did we start with? We started with 300. So how long means find t when the amount after time t is half of what you started with. Now I have an expression for a of t here, and I have an expression for a of t here. We put them equal to each other. Divide both sides by 300. That will give me a half, which I'm going to write as 0.5. I need to find t. I need to get it out of the exponent, so the base here is e. I'm going to take natural logarithms of both sides. Rule 3 of logarithms says this will come out the front, times ln of e, which is just the number 1. And I want to get t in days, so I'm going to divide both sides by that. So that's exactly how many days it will take. That's an exact answer, but it says to round it to the nearest day. Okay, so ln of 0.5 divided by negative 0.087. Okay, so 7.967 rounded to the nearest day is going to be 8. So it's going to take approximately 8 days. We only give the number. Do not include any words. So don't type in 8 days, just type in 8. Okay. Now, there's a lot to unpack with this one, but unpacking it is what we must do. Okay, so here's my formula. It says that the growth rate is 5.5%, and so that tells me that K is equal to 0.055. It says the population starts with 100 fruit flies. Okay, so now I can refine this formula. This is the formula that we're going to use. Okay, how many flies after 7 days? So we're being asked, P of t is the population at time t. So we're supposed to find the population after 7 days. And here's my formula. I just plug in t equals 7. And that's what I'm going to do. So 100, then I'm going to press the second key and the ln key, and 0.055 times 7. Okay, now it said to round it to the nearest fly. So 146.96 is going to be about 147 flies. The instructions clearly said round. If you just truncate, then you didn't follow the instructions. So rounded, it's going to be 147, and don't write flies, only give a number as your answer. Okay, so now we have a radioactive radioactive decay problem. So this has a half-life of 5 days. That means, now we don't have any formulas, so I'm going to use M for my formula. The letter is inconsequential. Okay. So M of T is the amount after T days. So this statement means that the amount present after 5 days is half of what you started with. And that's what you absolutely have to do, is take a statement and turn it into a formula. Now, if we start with a sample of 800 milligrams, so my starting amount here is 800. So the amount after 5 days is going to be half of what you started with. And I can also refine this formula because my starting amount is 800. All right, now I'm purposely going to choose T is equal to 5 because I want 2 expressions for M of 5. So using this formula, I'll get e to the power of k times 5, which I'll write as 5k. So I have M of 5 here, I have M of 5 here, and we put these two things equal to each other. Divide both sides by 800. That gives me a half, which I'm going to write as 0.5. Okay. Now, I'm going to have to find k, and then I'm going to further refine this formula, and I can finally get the answer. Take ln of both sides. So the 5k will come out the front, times ln of e, which is just 1. And this is my exact answer for k. Now, you're going to have to take k to at least 4 significant figures. So let's do ln of 0.5 divided by 5. Okay, so 0.1386. So now I have this formula. I can write it as 800 times e to the k times t, and that's going to be my k. And now the question is, how much will remain after 30 days? Find M of 30. So that's what I'm going to put in my calculator. 800, then the second and the ln key, negative 0.1386 times 30. Enter. Okay, so about 12.5. All right, colony of tadpoles grows exponentially and obeys this formula. So that's the formula we start out with. I'm going to have to find P of naught, and I'm going to have to find K. The colony starts with 175 tadpoles. Okay, so that's 175, and so I can refine this. Okay, so I don't need that anymore. After 7 months, there are 560 tadpoles. The population after 7 months is 560. And I'm going to take this formula and I'm going to purposefully put t equals 7. And I'm going to plug in t equals 7, so I'll have 175 times e to the power of k times 7, which I'll write 7k. These two are the same things, so put them equal to each other. Divide both sides by 175. let me see what that number's like. 560 divided by 175. Okay, 3.2. And then take ln of both sides. So this comes out the front. And so my k is equal to that exactly. So ln of 3.2 divided by 7. And I'm going to take that to 4 significant figures. 0.1162. So I need to put these together, and that's going to give me my formula where I can answer the question. So P of t is equal to 175 times e to the power of 0.1162 times t. Now, oh, it's just asking me for the growth rate. Okay, so the growth rate is going to be k times 100. So I take this and multiply it by 100. Okay, and that'll be 16.62%. Okay, and the last question, I have to put this into a calculator. I need to clear out list 1 and list 2. Okay. So here I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. And here I'm going to have 620, 762, 900, 1040, 1271, 1589, 1851, and 2155. And I'm going to go down and find exponential regression because that's what I was asked to do. And so my formula is going to be take it to 4 decimal places. That's my formula. Now it says, how much will the student debt be for the 12th month? So the month is my x value, so I put x equals 12 into this formula. So I'm going to have 522.9767 times 1.1964 to the power of 12. And I only round at the very end. So for the 12th month, round to the nearest dollar. Okay, to the nearest dollar. If I round that to the nearest dollar, I'm going to get that. Okay, and so that ends our session.